As a help. If you know with me, I'm running my Dragonborn. Let's get the line up here real quick because we're going to be getting Squiddy out here in a minute. Thermodynamics, Dragonborn from Balthiamol, so we got dragons over here as our god deities, and we're slaves to it because dragons are frosty fuckers. Inside of here about what's going on, obviously I'm setting on Amazon, we touch on some things, I had some Twitter numbers in there for where that's living, given the meta space today. One I didn't post after this, do you think meta saved the thing today? Not with Twitter being 33. So in other words, again, you got to be able to do this better. As far as the tread docs, the presentations, how circuit court warrants go, the fundamentals, the conditions. Here's an audit, the auditor, something to compare against, right? If you have nothing to compare against, how do you know that your top dog is your top dog? Later on we get wrecked by something, you go, wow, Larry, damn it, Larry. So I want to keep you on reviews of what I'm keeping an eye on. Again, it's a fundamental. Again, you'd have to go back. I'm still learning into it. I want you to make sure that we remember those kinds of things, and it's risky. That's where I'm still camped. That's what it is. I would be upset. I would be like, you need to get your sorry so and so get going, right? There's no reason to be nice to you now. Who else am I sparing on that mountain if it goes down? Going public. Anyway, at any rate, change out the parts. IMA, FBI, CIA,
This little
NSA.
toy is called a drinking bird. You put a cup of water in front of it, and its head dunks into the cup. Eventually, the head bobs up again, but then it goes right back into the water. If you don't know much about thermodynamics, the drinking bird might seem like it could go on forever without an external
the question,
source of
Mason
energy
Robot,
powering
is
it.
if you change
Perpetual
every
motion
part in
machine,
the
in
mill,
other
is it
words.
the
But
same
toy
machine?
isn't a perpetual motion machine
Think
because
about
perpetual
this.
motion is
Fiddle me this,
impossible
Johnny.
according to the laws of
If
physics. One of the
you
reasons
change
is
the
first
day,
law
is
of
it still the same machine?
thermodynamics.
Well, think about the work that goes into the changing field there, or the, not the changing field, they have it. In thermodynamics, it's a delta, but it's not a delta. It's something different.
One of the main
It means
goals of
something different.
thermodynamics is to describe
But
the
it's basically
transfer of
changing
energy.
field
We've
to
already
work
described
and
two
friction,
processes
or
as a
work and
transfer
heat,
of energy,
right?
work and
So
heat,
if
and they're both
yesterday's numbers
connected
in
to
the
each
mill
other.
were
As a
heat,
thermodynamic system does
and
work,
the
it
work I
loses
have to
heat.
do is a
When work
change
is
in
done
field, the
on a
calculus
system, it
numbers
gains heat.
you
So heat
do,
is converted to work, and work is converted to heat. Together, the work and
into
heat
heat and
transferred
work.
into or out of the system
And we're going to get
represent the
into it
change
here.
in its internal energy, which, as you might recall, is the total kinetic energy and potential energy of all the molecules in the system. This idea that the change in internal energy is equal to the change in work plus heat is so
work plus
fundamental
heat,
that it's
right?
known as the
Go
first
ahead, change
law
it.
of thermodynamics.
Go ahead.
So we can have an equation to use
Go
to
ahead,
analyze
change it.
problems. We
No,
write
it's
the first law
acceptable,
like this.
but there
The
will be
internal
heat.
energy, U, of a closed system is equal to Q, the heat transferred
Tell
to
you
the
the same
system,
thing I told that guy in that
minus
manager
W,
video
the
in
work
this year.
done
I don't know
on
what kid
or
it
by
was.
the
There he
system.
was.
It's
I was
important to
standing there.
remember that when we talk about changes in
Now,
internal energy,
on your own
if
time,
heat is transferred
you can
into
change
the
this.
system, Q is
You can
positive,
change this.
and if heat is transferred out of the system, Q is negative.
So if
And
I'm
if work
taking
is done
heat out
on
of
the
that system, we mark it as
W
negative.
is negative.
If
And
we're
work is done by
taking
the system,
work
W
out of this
is positive.
system,
Some
right?
textbooks will change those signs around.
If
so
I'm
it's worth
taking
keeping track
some
of
work
what the
out with
positives
this
and
to change the
negatives mean.
system,
Now you'll
they're
notice
still
that the first
relative,
law of
right?
thermodynamics describes only those two
Well,
factors,
did
work
you catch
and
it?
heat, as
Why is the
affecting a
change in
change
here
internal
relative
energy.
to
That's
talk about
because as long as the system is
thermodynamics,
closed,
FMA, all
meaning
day,
it's
Punk
isolated from the rest of the universe, there just aren't any other factors involved. The amount
The
of
law.
heat lost
Call
by the
me
system
maybe.
is
It's
exactly
nuclear is my
equal to
number.
the amount of work done by the system, and vice versa. So really, the first law of thermodynamics is just another way to describe the conservation of energy, which keeps coming up in our lessons because it's such a key principle of physics. There's always some kind of heat loss, like through friction. Even that tiny amount means that the motion can't continue forever. It will eventually run out of the energy it needs to drive the work it's doing. That's part of why the drinking bird isn't a perpetual motion machine. It relies on the energy it gets from the cup of water to power its movement. The bird is filled with a fluid that has a low boiling point, so it can easily change from
How
a
do you
gas
beat
to a
Sharps?
liquid and back.
The
With just a
strongest
slight
army
change
on
in
earth.
temperature.
How are we
There's
going to
some
beat it?
liquid at the bottom and some vapor at the top.
No,
When the bird's head
obviously
dips into the
AC,
cup,
but it's
it
not
gets
the
wet.
only
It
first
keeps bobbing
sergeant
back and forth for a
E6
while,
out there
and
in
as
this
the water
universe between
evaporates,
E0
it
and
cools
E1.
the vapor in the bird's head, which condenses into
E1
liquid,
to
creating a
E8.
partial vacuum in the head. That makes liquid
Change out the
travel up the
gambit.
tube. The head gets
Same
heavier,
gambit,
dips back
same
into the water,
IMA,
but the tipping makes a bubble
definition,
rise through
the
the
Joint
liquid
Chief of
into the bird's
Staff,
head,
done something
sending
different.
more liquid into the bottom and setting the little bird swinging and starting the cycle all over again. But it still needs the water for it to do its thing. Once the water in the cup runs out, the bird stops moving. Now, there are four basic types of processes where the thermodynamic properties of a system, generally an ideal gas in some kind of container, can change according to the first law. In each case, one property is held constant, volume,
Especially
pressure,
these two.
temperature, or heat,
This right here,
while the other properties
these
change.
two, oh
Variations
yeah,
of
baby.
all these properties are used in all kinds of machines, especially engines. First, there are isovolumetric processes where the volume is held constant, usually because the gas is in a rigid container, while heat is added or removed. As you add heat, the pressure of the gas will increase, and so will its temperature. As you
There's the
remove
number
heat,
right there.
the pressure and
The
temperature
little
will
number over there.
decrease. Isovolumetric processes
When you let
are
this
kind of
in
boring,
a
as
recondensing
thermodynamic processes
column
go. The gas is stuck inside its container.
by
No matter how much heat
reducing
you
the
add,
temperature
gas
and keeping
doesn't
all
do
the
any
fluid, or
work.
by
You're just increasing its
increasing the
internal energy.
space to
But
put the medium
isobaric
in the
processes,
position
where
of
the
the
pressure is held
air,
constant while heat is
where the
added or
pressure
removed,
is
are a
constant.
little more
You get
interesting.
into
Here,
why
the volume of the container is
1119
allowed
or
to
119
change,
for
usually
elements
because
is
the
more of
gas
a
can move
technical
piston. As you
problem
add
than
heat, the
anything.
volume and temperature of the
Or
system
teaching kids
increase,
how to
and as
do
you remove
chemistry
heat,
is like
the
an
volume and
aspirin
temperature
Tylenol
decrease,
reduction.
which
It's
means that an
technicals.
isobaric process
The
can do
systems
work.
in itself are
Here's
all
why.
written on
In
paper
earlier
like a saw
episodes, we've said
program.
that work is equal to force
Change
times
out all the
distance.
parts,
In this case, the
and
distance
it's
the
still
piston
freaking
moves.
Wednesday.
We've also said that pressure is equal to force divided by area, which means that force
Okay.
is equal to
So
pressure
again,
times
back to
area.
the
Here is the
how
pressure of the gas times
aspirin
the area
Tylenol
of the
reduction,
piston. So
lithium
work is equal to the gas's pressure
lithium
times the piston's
hydroxide
area times the distance it moves.
reduction
And one more
or
step. The
recrystallization
area of the
works.
piston times the distance it moves will be
Piston.
equal to the change in the volume of the container. So the work done during an isobaric process is equal to the pressure of
Piston.
the gas times the change in the volume. If heat is added, the volume goes up and the piston
Piston.
moves outwards, so the system does work. If you push the piston
What are you looking at for
inward,
points?
you're doing work
It's going
on the
out,
system,
isn't it?
so its volume
Right? The more
goes
you
down.
have
The third type of thermodynamic
those
processes
experiments,
are isothermal. That's where
clink,
temperature is
clink,
held
clink,
constant,
clink, clink,
usually
clink.
by
All
connecting the
rocks do
system
that
to a
on
much
the
bigger
average,
system.
mean, median,
Whose
and mode,
temperature would
sine,
take a lot of
cosine,
heat to
theta,
change. Known as a heat
or
reservoir,
whatever
the
that's
heat
going
or
to be
volume of the
given
system
that
is
angle.
then change very slowly so that the other properties can adjust.
And you tell
while the
that here. It was
temperature
like, right,
essentially
change in
stays
field, change in
constant.
work,
An
friction,
isothermal
heat.
process is kind of like an isobaric
If I'm
process,
taking out
in that if you add
heat, then I'm
the
putting
volume
in
will
work.
expand,
This is
so
a
the
known
system will
step
do
one.
work. But for
And we're
isothermal
just
processes, you can't use
arbitrarily,
that
remember
simple
how they were
W
like
equals P delta
sometimes
T
in certain
equation,
math books,
because the pressure does change.
you get that
Instead,
wrong,
you
you'd be
need to
totally
take the
upside
integral
down
of the
and
pressure with respect
not
to
know
volume.
what's going on.
This way, you're still
Sometimes you
calculating
forget
work, but you're
to
taking the changes in pressure into account too. Another
do
difference
it.
between isobaric
So
and
again,
isothermal processes
Mason
is
Robot,
that since
if you
temperature is
change
held
every part
constant
in the
in
stone
isothermal
mill from
processes,
a stone
the
mill
internal energy
into
of the
one
ideal
extra
gas
part
can't
in that
change.
mill,
And the first law of thermodynamics says that heat
is it the
minus
same
work
mill?
is equal to the change in the internal energy of the system.
Now that
In this
we've
case,
been
0.
here,
So the
right,
work
and then
done
they
by
add
the
new
system will be
saws,
equal to the amount of heat
right?
added,
They want to add in
and
a new
vice
saw
versa.
to here.
Finally,
Everything
there are
is going to get
adiabatic
compressed, but
processes
for the
where
most
no
part,
heat
they'll
is allowed
stay
to
in
flow in
units.
or out of the
As
system,
long as that's
but the gas can
congruent to the
expand or
standards,
be
I can
compressed. Again, the
operate, or
equation
we
for
can
the
shift
first law
things
of
around. Doom Slayer
thermodynamics
up here,
helps
doing
us
some
out here. Q
speedrun
is
hacks,
0 because
speedrun
the heat of the
hacks.
system isn't
Misses
changing,
something, lets
but
one
the
through on their
internal
common
energy of the
play,
gas
but
can
winds up
change.
making two
So the
in there
system can
because
do
drops a
work or
grenade
have
on
work
him and
done on
clears
it.
out
In
a
fact, the
faster
change
run.
in the
Now
internal
go
energy of the
figure,
gas
Sharps.
will be
Right?
exactly
Go figure
equal to
yourself.
the negative of the work. But this is all just